So we've got a question here from the products and processes course. Particle board is cheaper than plywood. Why is this, and why should I use more expensive plywood?
Okay, that's a good question.
This is a good question.
Good question. It's maybe not too simple to answer. Okay, so I mean, particle board was actually originally designed as a way of using waste material. So basically, I won't say anything can go into particle board, but I mean, one doesn't need the same requirements in terms of the raw materials you need in plywood. For plywood, you need to have a good quality logs, and they need to be of a certain size. So they're more difficult to come by, and the process is a little bit more involved because you have to create a veneer sheet, and then you need to lay that up, and that's often still a manual process. So it's more involved. So it becomes more expensive to manufacture. The advantage of plywood, of course, is as a structural material, it's a really good material. I mean, it's been around. It was first used in Egypt in the days of the pharaohs. That's when it goes that far back.
I was going to say aeroplanes, but they didn't make aeroplanes back then.
No, it's
as far as we know.
Maybe, I don't know. Yeah. But basically, it's a super good structural material.
What did they use it for? I'm just fascinated by this. What did they make out of plywood?
A sarcophagi.
A sarcophagi?
Yes.
All right, not kitchen units.
I don't think so. Maybe they did, but there's none of them surviving as far as I know.
There was no IKEA
IKEA
equivalent
around then, no, not in the
reign of Imhotep.
So it's a super good structural material, which is the advantage. So it has structural properties that particle board doesn't have. I mean, particle board.
Because of what?
Because of the fact it's made of particles, and particles are joined together. It's a kind of a discontinuum.
And what's the problem with particles?
There's no problem with particles per se. That's actually really difficult to say.
Yeah.
There's no problem with particles per se.
So why isn't it as good as plywood then?
Because of the structural structure. The structural structure.
The structure. I've got him. Structural structure. Call that an explanation.
It's to do with structure.
It's to do with orientation. That's what the word you're looking for.
Not entirely. It's partly due to orientation. Yeah, of course it's due to orientation.
OSB is better. Like particle board, it's all over the place. And OSB is better.
OSB is better, and OSB is
not as good as plywood.
It's not as good as plywood because I mean, yes, of course, because there is the orientation of it. But if you think about plywood, you have kind of veneer sheets where the grain is running pretty much in one direction. So you have a unidirectional laminar with a veneer sheet. Okay. So you build that up to create your kind of your multiply laminate plywood structure.
Do you balance
no air gaps
plies?
In between.
Do you balance the plies?
Of course, you have to have balanced plies. Yes.
Do you have them perpendicular to one another?
One has them perpendicular.
Do you always do that?
You don't have to have them. No, well, it depends what properties one wishes to have.
I'm seeing what he knows.
You can actually design based on laminate theory what you want basically. Typically, though, it's a kind of a cross ply where they're orthogonally oriented. In a balanced structure, so that's 3, 5, 7, 9.
I do believe that you know what you're talking about.
Yeah, glad you do, because somebody does. But with particle board, you don't have that. But also then the fact that you're using particles and you have the overlap and the poorer bonding between them, that compromises the stress transfer between the particles, so you don't get the same strength and stiffness as you would do with the plywood. So yeah, you're right. I mean, it's to do with structure, and it's to do with orientation. A little bit of each, and also the way they are configured together. So this is an important thing as well.
Yeah. So we've got some bits here.
We've got. Is
that MDF?
Am I allowed to break these?
Yeah.
Can we break them? So here's an example. Is this plywood? So I'm going to try
break this one.
I'm going to try to break this plywood first of all. See if I can do that. I can hardly bend it. You try.
Yeah.
Let's see what happens. I can't do anything with this one.
Looks pretty good. Birch, is that?
That's birch.
I can't hardly bend it.
Okay, let's have a look at this one. This is now plywood. It's a little bit thinner, admittedly. Is it? A wee bit thinner?
Tiny
bit thinner. Okay, let's see if I can do anything. Can I bend this? No, I can break it. Like a Kit Kat.
Yeah, I'll have a bit.
Have a break.
Have a break.
Have a break. Have a Kit Kat.
That's an advert. You can't say that.
Okay,
I think that's pretty good demonstration.
Yeah.
OSB.
OSB.
That's probably. I reckon
you can't break that.
Yeah.
I reckon I couldn't.
He's done it.
Don't have my own strength.
I couldn't break it.
No. What's this one?
You won't break. Oh yeah, you might be.
Is this MDF?
MDF, I think.
Is it?
Okay. Is it okay if we break all these?
Sorry. Sorry. Okay. Yeah. Does that
I think that's
demonstrate?
enough.
Yes.
I think that's enough.
Yeah. Plywood,
Yes.
particle board.
Yeah.
But both useful for what they. I mean, plywood is used for structural applications
Yeah.
mainly. Particle board not.
Yeah.
Structural applications, but still a useful.
Yeah,
material.
yeah. I know some people that made a catamaran out of plywood, and they stitched it all together with
Yep.
copper wire,
Yep.
and then they epoxied the whole lot,
Yep.
and they went around the world in it. I don't think you'd go around in a particle board catamaran.
No.
Don't think that'd be advisable.
No. No. Definitely not.
Yeah.
That's a.
I'm very impressed with your strength, I have to say. I had
Don't have
no
any
idea.
strength.
I'll treat you with more respect in the future.
So you should do.
Okay, I was a little bit surprised when Mark managed to break this, but if you look at, you may not be able to see it so well on the camera. Should I bring it up a bit closer? It's okay there, is it? You can zoom in on it. It's not the wood that's broken, it's the interfaces. And the same here, if you look at those breaks, I mean, these are a lot longer because the strands are longer. So the longer you make the wood strands, the tougher it would be, really, because I mean, essentially you're causing a failure at the weak interfaces.
Yeah,
aren't you?
yeah. I mean, you have much more. I mean, in the OSB, you have much more greater overlap between
Yeah.
the particles because they're the strands because they're that much larger.
Yeah.
So even though there's probably similar amounts of glue in there holding it together, the fact that you've got that nice overlap is really helping.
But you're not breaking the wood.
No, and certainly not breaking it with this because you have kind of continuous strands in here. So and they're glued together very, very, very tightly. So you're not going to. You can barely even bend it.
Yeah, I could hardly bend that. Yeah.
So yeah.
Okay. Yeah.
Good. Yeah.
You still think you're really strong then?